Torque problem number 13. Find the force needed for the system to obtain equilibrium. So that's the force that we need to find. So first you need to find the components of all these vectors that are not aligned with the vertical. So that will be these ones right here is your F3y. This is F1y, and this is F2y. So label those vectors, the components, as y because it's vertical components, and the corresponded to this main vector. So we need to bring all those vectors that are not aligned with the vertical to this direction. So now we are going to make a table to organize all these forces, the components, and we are using sine or cosine. So this will be all your Fy, in this case will be your F1y, F2y, and F3y. And in this column, we are going to use the formula for each of these components. Now, first we need to find the angle adjacent to this component. So if this is 60, since this is a right triangle, so this angle is 30 degrees. So this is 90, so this is 45. And now you're gonna look this section upper here. So this is 40, and that will be 50. So 90, right? So 50, and this is 45. Perfect. So to find your F1y, for example, so because it's adjacent to this angle, so cosine of 45 is equal to adjacent over the angle, the vector, the resultant, or the hypotenuse, which is 15. So if you do cross multiplication, so your F1y is 15 cosine of 45. So you are going to follow the same method for F2y and F3y. Same thing that I did here. So that's why I'm going to write like a general formula for all three components. That is Fy is the F, or the resultant, or the hypotenuse, times cosine of the angle. So your F1y, for example, it will be 15. So that is the main vector, times cosine of 45. F2y is F2, which is 17, times cosine of 50. And finally, F3y is this vector, which is 17, times cosine of 30. So here we are going to plug in your calculator and find the solution, or the result of this multiplication. F1y is 15 times cosine of 45, which is 10.6. So F1y is 10.6 newtons. F2y is 17 times cosine of 50, which is F2y is 17 times cosine of 50, which is 10.9 newtons, and F3y is 17 times cosine of 30, which is 14.72 newtons. So your first step is find all Fy's. Now, our second step is to identify the forces that produce clockwise and counterclockwise. So, for example, this is the fulcrum. So you fix the fulcrum, and now you work with the forces that are perpendicular to this rotational motion. So F1Y will produce a clockwise torque, F2Y a counterclockwise torque, F, the force that we are looking for, is clockwise, and F3Y is counterclockwise. So this is counterclockwise, clockwise, this is clockwise, and this is counterclockwise. Group them using the torque equation. So the torque equation states that the sum of all the torque that are clockwise is equal to the sum of all the torques that are counterclockwise. So for clockwise, we have F times the distance to the fulcrum, which is 2, plus F1Y times the distance to the fulcrum, which is 5. For counterclockwise, we have F3Y times the distance to the fulcrum, which is 5, plus F2Y times the distance to the fulcrum, which is 5. So 2F is equal to F3Y plus 5 plus F2Y, times 5 minus F1Y times 5. So 2F here is, 5 is common, so you can do 5 multiplied by F3Y is 14.72, F2Y is 10.9, minus F1Y is 10.6. So now in your calculator, so my F is 37.55 newtons, and that's my final answer. So this is the force, the magnitude of the force required to bring all the system in equilibrium.